All right. Um, Talking about equivalent fractions. The first part is a two-parter again. The first part is equivalent fractions. Well, let's talk about what an equivalent fraction is. An equivalent fraction is, are fractions. So at least two or more fractions that have the same value. We have 1/2 or 1/2 is equivalent or equal to 2/4, or 2/4. So let's talk about how these are equivalent. So a lot of us like to use the example of a pie or a cake, or a pizza, kind of whatever you like to think about it is, or as, excuse me. Um, so let's go ahead and talk about them as a pizza. So once again, I'm still using a mouse, so please forgive me. My drawings might be not as pretty, but and 1 to 2 using the same operation. So remember, addition, subtraction, multiplication, division, and the same number. So how could I do it? What could I do to the 1/2 here to create 2/4? Well, what can do is we can multiply both the top and the bottom. Now, what we do to one, we have to do to the other. We multiply the top and the bottom by 2. Now, if you multiply 1 times 2 gives you the new top of 2. If you multiply 2 times 2 gives you the new bottom of 4. This is what makes it equivalent. We multiply both top and bottom by the same number to create the new fraction. So let's go ahead and look at another example. Okay, so let's go ahead and find the missing part of the equivalent fraction. So we have one piece of it. We need to create or come up with the other number. So we ask ourselves, well, how did I go from 5 um, 5 to 15? Or what did I multiply 5 by to create 15? Now, of course, you can use your multiplication charts to try to figure this out. Excuse me. But of course, 5 times 3 gives me the new denominator of 15. So therefore, we have to do the same thing to the top. We have to multiply 2 times the same 3 gives us 6. 15ths are 5 slices and 15 by 6. Just a coincidence that's exactly the same as the other one. It's not always going to be 6 like the other one we saw up there was 2 and 3. So now we go ahead and multiply 5 by 6. And that gives us our new denominator of 30, because 5 times 6 is. Your own. I want you to give these two a try. So pause the recording here and give these two problems a try. You're going to find the missing part of the equivalent fraction, just like we did above. So go ahead and take a moment, pause this, and go ahead and give these two a try. All right. Now that you're back with me, let's go ahead and look at see what we should have done. What is this missing piece? What should have been? So the question is, how do I go from 7 to 28? Well, hopefully you multiplied by 4. That means we multiply the 10 by 4 to create. You got the missing piece is 40. Same thing. And that creates, that means we multiply the top by 5, 30 over 55. All right, so that's how you create fraction. And we accomplished this by dividing. When we found equivalent fractions, when the numbers went up, we multiplied. So if we're doing the opposite, numbers go down. The opposite is division. Now, the object is to try to find the greatest common factor. Well, that's not always the easiest thing to do. So all we really need to find is a common factor to get us started. Now, finding the common factor won't get us directly to the answer, unless it's, of course, the GCF, or greatest common factor, but it will help. So let's go ahead and look at the same example we had on equivalent fractions. 2/4 is equal to 1/2. 2/4 can be reduced or simplified to 1/2. 1/2 is the simplest form. So let's talk about how we can do this. So we have to know a common factor. How do I go from 12, sorry, not 12, but 4 to 2 and 2 to 1? Well, of course, we have to divide. Because it's getting smaller, we need division. And we ask ourselves, what can I divide both 4 and 2 by? We divide by 2. We divide both top and bottom by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And now this right here is our simplified fraction. This is in its, or reduced fraction. It's in our simplest form. So that's what we're looking to do today for reducing fractions. So if we look at the next one, 3/9. So we got to think about what factors do we have of these. What are factors of 3? Well, if remember, factors are two numbers that multiply together to create 3. Well, since it's prime, it's just simply 1 times 3. What multiplies together to create 9? 1 times 9. And we also have 3 is in common for both of these. That means if we can divide by 3, which we should be able to divide by 3, that will give us a simpler fraction. So let's go ahead and do the division. 3 divided by 3 is 1. 9 divided by 3 is 3. So we always want to check to see, is this in simplest form? We check to see if it's in simplest form to see, can I divide 1 and 3 by a number? Can I divide 1 and 3 by a number? Well, you can divide it by 1, but is that going to change anything? No, because 1 divided by 1 is 1. 3 divided by 1 is still 3. So this is your simplest form. You've reached the reduced fraction. So we can't reduce it anymore. Well, this was nice because we found the GCF of 3 and 9, which was 3. So that made this one pretty easy. So let's go and look at another example, one that has multiple ways of actually doing the problem. So if we look at this, this is 6/12 or 6/12. So we could go through and we could write out all the factors of 6. Oh, that's not 6. That's going to erase that. Let's go ahead and put a 6 up there. All the factors of 6, which are 1 times 6 and 2 times 3. Well, that's a bad 3. Let's fix that real quick. And 3. And we think about the factors of 12. Let's go ahead and look at 1 times 12. What else? We have 2 times 6. Forgot to put the multiplication sign between. And we have 3 times 4. All right, so these are all the factors of each of them. And so we would like to find the greatest common one. Well, the greatest common factor, of course, here is 6. The GCF of 6 and 12 is 6. So we could easily divide both of these by 6. And what you do to the top, you have to do to the bottom. And then come up with our reduced or simplified fraction. 6 divided by 6, of course, is 1. 12 divided by 6, of course, is 2. And of course, we double check. Can I divide 1 and 2 by anything? No, I cannot. So this is your simplified or reduced fraction. Now the question is, what happens if we can't find the GCF real quick? Start off with 6/12 again. Numbers get smaller. Remember, the fraction is equivalent or the same value. And I get 3, and then 12 divided by 2 is 6. So I get smaller numbers, but I always have to double check. Can I divide 3 and 6 by a number still? And the answer is yes. I can divide them both by 3. So let's go and divide both of these by 3. Divide by 3, divide by 3. And the answer is 1/2. Because 3 divided by 3 is 1, 6 divided by 3 is 2. And here is your simplified or reduced fraction. So here's the time now where you get to try it on your own. Go ahead and reduce 8/12 to the simplest form and 15/30 to the simplest form. So go ahead, pause, try this on your own, come back, and we'll talk about our answers. All right, welcome back. Now, the way you might have done it might be different, okay, because there's different ways. As long as you found a common factor, your answer should be the same in the end. So if I look at this, if I look at 8 and 12, if you think about the greatest common factor both of these have in common, I believe the greatest common factor they both have is 4. So if I divide by 4, I should get 8 divided by 4 is 2, and 12 divided by 4 is 3. This is your simplified or reduced fraction. If we look at the second one, now you could have noticed that 15 is the greatest common factor between 15 and 30. If you didn't know that right away, it's okay. But I do know that 5 is. So I want to do this in 2 steps just to show you that this way is okay. Okay, you could have done it by 5 first. 15 divided by 5 is 3. And then 30 divided by 5 is 6. But then you always have to double check. Can I divide 6 and 3 by a number? And of course the answer is yes. So I can divide it by 3. So let's go and divide both top and bottom by 3. And this should give us our simplified fraction. 3 divided by 3 is 1. 6 divided by 3 is 2. There is 1. Half of 30, so of course that would make sense. All right, so that's your last lesson on reducing fractions. Remember, if you need to, you can always go back up and check it out again or check out a particular part. But now you may go ahead and start your lesson.